So we're going to look at today our intro to chapter 6 in our first section, section 6.1, which is an introduction to chemical bonding, and really look at what holds atoms together. This chapter is broken up into 5 sections. The first section is the introduction, like I mentioned. The second section is covalent bonding. The third section is ionic bonding. The fourth section is metallic bonding, and the fifth section is on the shapes of small molecules, or what's called molecular geometry. So this first section really just talks about ionic and covalent bonding. Metallic, it is one of the sections. It's very short in this chapter, but usually the main two types of bonding are ionic and covalent. Okay, but before we get to those, just looking at what a chemical bond is, and it's this attraction between the valence electrons and the nuclei of different atoms that holds those together, that makes new substances. When a bond forms, it is a chemical change. The reason this takes place is that the atoms that are separated are higher in energy than they would be when they're combined, and this need to become lower in energy allows them to bond. Atoms seldom are by themselves in nature. There's only a few elements that actually do that. So bonding is a very important part of chemistry. And like we mentioned when we looked at in chapter 4, our electron configurations, it's those outer valence electrons that are involved in bonding. Okay, so the first type of bonding is the ionic bond. It's formed by transfer electrons. So what we get there are positive ions, or cations, if you can remember from last chapter, and negative ions, which are anions. That attraction, that electrostatic attraction, also called a Coulombic attraction after Coulomb's law, allows those atoms to bond together. Okay, the most common ionic substance is probably sodium chloride, NaCl, where you have a sodium ion that transfers one of its electrons to chlorine. You get the sodium cation, the chloride anion, and they bond together. We're going to talk here soon about electronegativity. We did that last chapter. Remember, that's that attraction for electrons that take place in a chemical compound. When there's a great difference in this electronegativity, the atoms, we talk about them being transferred. So it's an ionic bond. Okay. Our next type of bond is a covalent bond, and these are formed by sharing the electrons. Their electronegativities are similar. The difference is less than that of 1.7. So instead of transferring to one side or the other, one atom or the other, they share. And this is another attraction that leads them to form a new substance. Within covalent bonding, there are two different types. There's what we call a nonpolar covalent bond, and that is where you have an even distribution of charge. So the atoms that share the electrons share equally. So there's no poles. That's what the nonpolar is. You don't have a negative side or a positive side. They share very evenly. The best example of nonpolar covalent bonding is when two atoms that are the same bond together. They share equally. They have the same electronegativity, and they have a nice symmetrical electron cloud, as you can see here around H2, which is the example. The other type of covalent bonding is called a polar covalent bond, and that's when you have an uneven distribution of charge. So it's not great enough to actually form an ionic substance, but the charge is not evenly distributed. The more electronegative atoms, so in this example, the fluorine holds the electrons more of the time. So when there's more electrons around fluorine, it gets what we call a partial negative charge. We don't label it just as negative because it's not an ion, it's partially negative. And then in this example, the hydrogen, which has a lower electronegativity than fluorine, has a partial positive charge because the one electron that it does have resides mostly around the fluorine. Okay, these substances, these polar covalent substances, have much different properties than nonpolar covalent substances. Okay, so here's our electronegativity periodic table. Okay, you can kind of use this as a reference if you look back at the PowerPoint for this section and for sections 1 through 4. And we're going to use this actually to determine bond type, whether it is ionic, whether it is polar covalent, or non-polar covalent. So if you look at this chart, okay, and this kind of gives you the cutoffs, and this isn't be all end all. You can have some minor differences with electronegativity difference in bond type. The only real way to know is through experimental evidence. But Usually a difference of greater than 1.7 between the two atoms, we consider that bond to be ionic. If the difference is between 1.7 and zero point 0.3, we consider that to be polar covalent. So they share, but not quite evenly. And then between zero point 0.3 and 0, we consider that to be nonpolar covalent. The true only nonpolar covalent bond is when you have zero difference. Even with a little bit of difference, there is some separation of charge, but not much. Okay, so down here's just an example. These are very simple. You just look up the electronegativity values from the periodic table that's on the previous slide, and then you just subtract them to get the difference. You don't use negatives. Large electronegativity value minus the small electronegativity value will give you the difference. So if you look at NaCl and you go to look this up on the previous slide, okay, here's Cl, it's right here, it's 3.0. And here's sodium, it's 1.0. And you subtract those two, you get a difference of 2.0. And if you slide that in about right here, that shows you that the bond between Na and Cl will be ionic. Okay? Now, the bond between O2, which is O bonded to O. If you go back and look up oxygen right here, it's 3,5. 3,5 minus 3,5 gives you a difference of 0. That is pure nonpolar covalent. And you really don't even have to look those up. When you have the same atom bonded to itself, it is going to be nonpolar covalent. And then lastly, here's H2O. You don't multiply, you just look at the two atoms, hydrogen and oxygen. You don't multiply the hydrogen value by 2 or anything like that. So hydrogen, here it is at 2.1. Here's oxygen at 3.5. We make the subtraction. 1.4 is the difference, and that is right in here. It is polar covalent. So that's one way to look at bond type, is to actually do the math between electronegativity difference. There's one other, if you don't have an electronegativity periodic table, that you can usually count on, and here it is right here. Ionic bonds usually form between metals and nonmetals. Metals usually have very low electronegativities, and nonmetals usually have very high electronegativities, so those differences are usually greater than 1.7. And with covalent bonds, you really can't tell if it's going to be nonpolar or polar unless it's the same atom bonded to itself, but it usually is two nonmetals. Usually their electronegativity values are pretty large, but pretty similar. And when you subtract those, you get a difference of less than 1.7. Okay? So I hope that helps with a little intro to ionic and covalent bonding. Like I said, moving forward, we are going to go over each type in detail and then eventually get to some shapes of these molecules that are held together with covalent bonds.